Now we have discussed another type, indeterminate form. I have already discussed 0 by 0 or infinitive by infinitive, and second type of 0 into infinitive or infinitive into 0. How can solve that type of problem? Now third type of, if infinity plus 2 this be equal to infinitive, so you can say that 2 this be equal to infinitive minus infinitive. This implies another way, infinitive minus plus, you can also say that 2 by 3 that is infinitive minus infinitive. Okay, so now next one, 2 plus minus 1 by 3 this be equal to infinitive, so you can say that minus 1 by 3 this be equal to infinitive minus infinitive. Okay, it means you cannot say what is the exact value of infinitive minus infinitive is 2, sometimes this one. Okay, it means you cannot set the what is the exact value of infinitive minus infinitive. It means it is also called indeterminate form, or you can say that is meaningless. Okay, clear or not? So how can solve this type of problem? So first of all, if question look like this one, if at x tends to 0 or x tends to a we got the function that is infinitive minus infinitive, then how can solve? I know that infinitive minus infinitive means you can say that a divided by 0, or you can say that b divided by 0, whatever be the a and b, 1 2 3 minus 1 minus 5. You can also say infinitive is also written as a divided by 0 minus b divided by 0, where a and b is not equal to 0, whatever be the value but not equal to 0. It is not equal to 0, it is not equal to 0. Okay, whatever 1 2 3 4 minus 1 2 whatever be the value, but it is not equal to 0. Clear? So how can we solve? In infinitive minus infinitive, it is written as a divided by 0 minus b divided by 0. It means if take LCM, that is 0, a into 0 minus b into 0, so you can say that is 0 by 0. After getting 0 by 0, you can apply L'Hospital rule. I have already discussed that is what is the L'Hospital rule in previous lecture. Divide numerator and denominator divided by dx, divided by with sorry, not divided, it is differentiate with respect to x. Okay, suppose that if limit x tends to 0 or x tends to a, here f of x and here g of x, at x this be equal to a, we got if f of a this be equal to 0 and g of a also 0, then differentiate both with respect to x, that is prime of x, and it is also g of prime of x. Okay, if x tends to a, if x tends to a, we got f of f prime a this be equal to 0 and g prime a also 0, then again differentiate with respect to x and put this value. Otherwise, if suppose that f prime a is not equal to 0 and this one is 0, so you can find this is the final value. Okay, so but if got this type of function, then you can differentiate again and this one also again. Okay, this is L'Hospital I have already discussed. Okay, according to L'Hospital rule. Clear or not? That is the third type. That is type 3. This is also indeterminate form. Clear or not? First indeterminate form 0 by 0 or infinity by infinity, I have already discussed in previous lecture. And second one I have already discussed 0 into infinitive or infinitive into 0 type of function. It's called indeterminate form, and how can solve that type of problem. And this one is a third type of problem. Infinitive infinitive minus infinity, it is also indeterminate. Why? Because of it is not exact value. What you can say that infinity plus 2 this equal to, you can write now here also written as, here also written as. It means infinity minus infinity is not exact. What is the exact value? You cannot say here. Sometimes some students say 2 by 3 minus 1 by 3. Okay, you cannot define, you can say that it is not defined, it is meaningless. Okay, not exact value. So how can we solve this type of problem? So first of all, if this type of problem is given like this one, then it is written as a divided by whatever, converted like this one, and after that take LCM, and after that we got 0 by 0. It means here apply K. Here if got 0 by 0, then apply L'Hospital. Not apply here L'Hospital. Why? Because of it is not 0 by 0 form. So first of all, make 0 by 0 form or infinity by infinity form, then apply L'Hospital rule. If 0 by 0 form, then you can say that as a function, here f of x, here gx, x tends to a, at x is equal to 0, we got 0 and is also 0, then apply L'Hospital. Then we got this one. If again we got this one, then apply L'Hospital rule, and we got this one. Okay. Now we have take some problems. Then all doubt are clear. Okay. So first of all, make it. This is type 3, indeterminate form. That is sec x minus 10x. Okay. Now first of all, check. At x this equal to 0. If put this, at x is equal to pi by 2, then we got sec pi by 2 minus tan pi by 2. Okay. At limit x, at x is equal to pi by 2. What about this value? This is infinity minus infinity. Okay. If put this value, that is minus infinity, infinity, and this is also infinity. So we got in infinity minus infinity. Infinity minus infinity. It is, you can say that is indeterminate form. So how can solve this type of problem? First of all, make this this one, make 0 by 0 form. Okay. Now so only that is pi by 2. It is, if this one is written as 1 by sec is written 1 by sec is written as 1 by cos x, that is 1 by cos x, and it is written as sin x divided by cos x. Okay. Now limit x tends to 0, x tends to pi by 2, then it is written as 1 minus sin x divided by cos x. Okay. Now after that 1 minus sin x divided by cos x, it is written, if put this value x is equal to pi by 2, then sin pi by 2, that is 1 minus 1 is 0, and here if put this value pi by 2 cos pi by 2, it is also 0. So you can get 0 by 0 form. You can then apply L'Hospital rule. Clear or not? If you put this value, then we got 0 by 0, because if x is equal to pi by 2 here put, then 1 minus sin pi by 2, that is 0, and cos pi by 2, that is 0. So we got 0 by 0 form, means L'Hospital rule is applicable. Then apply L'Hospital rule, means differentiate this one with respect to x, and this one is also with respect to x. So limit x tends to pi by 2, would differentiate this one, 0 minus sine of, that is we got cos x, here minus sin x. So that is, if limit put x tends to pi by 2, then that is cot x. If put this value cot pi by 2, what about cot pi by 2? That is 0. So final answer is 0. It is right answer. Clear or not? So first of all, check if this one is given, then put this value x is equal to pi by 2, then we got infinity minus infinity, because sec pi by 2 and minus tan pi by 2, it means that is indeterminate form. Okay, I have already said, I have discussed, this is called indeterminate. So how can solve this type of problem? Again, this one is converted 1 by cos x minus sin by cos x, and take LCM, we got 1 minus sin x divided by cos x. If x is equal to pi by 2 put here, then 0 by 0 form, then it means you can apply L'Hospital rule. Okay, with respect this one differentiate with respect to x, and this one also with respect to x, then we got 1 minus cos x, divided by 0 minus cos x divided by minus sin x, then we got cot x, and put this value pi by 2, x is equal to pi by 2, then we got cot pi by 2, that is 0. This is the 0 is the final answer. Make it. After that we have discussed another question. Now limit x tends to infinity. If put this value, that is infinity minus infinity plus infinity, so you can say that infinity minus infinity, you can say that is also indeterminate form. So how can resolve it? Okay, so how can resolve it? So first of all, it is written as limit x tends to infinity, x minus x square plus x. If this one rationalize, x plus under root x square plus x divided by x plus under root x square plus 1 x, then we got limit x tends to infinity, that is x square minus x square minus x divided by x plus x square plus x. So if we put this value, x tends to infinity, then we got minus x divided by x plus under root of x square plus x. Okay, clear or not? If take minus common, x is common, then we got 1 plus under root of 1 plus 1 by x. Okay, now after that limit x tends to infinity, we got 1 divided by 1 plus under root of 1 plus 1 by x. If x is equal to infinity, then we got that is 1 by infinity, that is 0. Okay, so written as 1 upon 1 plus 1, that is final answer is 1 by 2. 1 by 2 is the final answer. Minus 1 by 2, minus 1 by 2, because of minus is here, that's why minus 1 by 2 is the final answer. Make it. Another this type of question, if you can put this value x is equal to infinity here, then we got also infinity minus infinity. This problem also with the help of rationalize. Now this one, first of all, if any doubt, then put this value x is equal to infinity plus 1, that is infinity, here infinity plus 1 infinity, so infinity minus infinity, that's indeterminate form. So again here, if x square plus x plus 1, it is first of all put written here, and now rationalize x square plus x plus 1 plus x square plus 1 whole divided by x square plus x plus 1 plus under root of x square plus 1. Okay, then we got limit x tends to infinity plus 1 minus x square minus 1 whole divided by under root of x square plus x plus 1 plus under root of x square plus 1. Okay, now limit x tends to infinity, then we got x square cancel, that is x divided by under root of x square plus x plus 1 plus under root of x square plus 1. Clear or not? If put this value, not put, first of all take common in numerator and denominator. Numerator is only x, denominator if take x is common, then we got 1 plus 1 by x plus 1 by x square and plus under root of 1 plus 1 by x square. If put this value x tends to infinity, then we got if x put this x tends to infinity here, then under root of 1 plus 1 by infinity plus 1 by infinity to the whole square. Okay, plus 1 plus 1 by infinity to the whole square. We got 1 upon, that is 1, and here also 1. So 1 by 2 is the final answer. find A, B, C and D. Our target is, this question is given like this one, if x tends to infinity, then this one minus this one, this will be equal to 4. Then what about value of A, B, C, D? Our motto is determine, evaluate the value of A, B, C, D constant. So how can we determine? First of all, put this value, if x tends to infinity, then we got infinity minus infinity. It means that is indeterminate form. Clear or not? Clear? If put this value x tends to infinity, then infinity minus infinity, but this will be equal to written 4. It means that is a finite value. Okay, but here got infinity minus infinity. So first of all, rationalize this one into this one. Then we got, finally we written as 4ax cube plus 3x square plus bx plus 2 minus x power 4 minus 2x square plus c into x square minus 3x plus d divided by under root of, after rationalization, okay, we got 4x power 4 ax square, sorry, ax cube plus 3x square plus bx plus 2, and here plus written as x to power 4 plus 2x cube minus 2x square plus 3x minus d. After rationalization we got this one. Okay. Now after that, limit x tends to infinity, upper part x to power 4, x to power 4 is the cancel out, x cube, and this one is x cube. Okay, so it is written a minus 2 into x cube plus c plus 3 into x square plus b minus 3 into x plus d plus 2, clear, divided by, it is written as x to power 4 plus ax cube plus 3x square plus bx plus 2 plus under root of x to power 4 plus 2x cube minus cx square plus 3x minus d. Clear? This will be equal to 4, this will be equal to 4. It means this is the finite value, that is finite value. It means here also finite value. If x to power 4 is common, then we got x square. Okay. Upper highest power is 3, lower upper in mean numerator highest power x to power 3, but here highest power is 2. Okay, and this one is got finite value. It means if this denominator is equal to 0, sorry, this coefficient is 0, means a minus 2, you can say that right now, since limit is finite, so the degree of denominator must be 2. Okay, so a minus 2, this will be equal to 0. If a minus 2 this will be equal to 0, it means that is a this will be equal to 2. It is clear कि if a this will be equal to 2, then that is finite, then we got finite value, otherwise not possible. Okay, if a this will be equal to 2, then numerator highest power 2 and denominator highest power 2. Okay, if this one is 0, then what about, first of all make it, after that we are solving. If this one is 0, you can say that then it is 0. Clear? And after that we can common x upper part, numerator is x square, denominator also common x. First of all written x tends to infinity, if common x square in upper, then we got c plus 3 plus b minus 3 divided by x and d by 2, sorry, d plus d plus 2 divided by x square divided by, written as, if x square is common, then we got x square, sorry, that is 1 plus a divided by x plus 3 divided by x square plus b divided by x cube plus 2 divided by x to power 4. Clear or not? Now plus under root of, put this value common also, so 1 plus 2 by x minus c by x square plus 3 by x cube and minus d by x power 4. This will be equal to 4 or not? Clear? If put this value, if put this value x tends to infinity, put this value x tends to, if x is equal to infinity, if put x tends to infinity, then we got, that is c plus 3 divided by 1 plus 1, that is 2, this will be equal to 4. So c plus 3, this will be equal to 8. So c, this will be equal to 5 and a, this will be equal to 2. I have already got a, this will be equal to 2 and c, this will be equal to 5. And what about b and d? B, so you can say that a, this will be equal to 2, c, this will be equal to 5, and you can say that b and d are any arbitrary constant, are any arbitrary, or you can say are real number, any real number, really real number. So final answer is a, this is equal to 2, c, this is equal to 5, and b and d are any real number. Now limit x tends to 0. If put this value, then we got 1 by 0, that is infinitive, and 1 by 0, that is infinitive. So infinitive by infinitive. So how can solve this type of problem? If it is written as, also take LCM, then x tends to 0 into sin x plus x. Apply a square minus b square formula, then you can written as this one. Okay. After that, that is x square into sin square x. Now limit x tends to 0, sin x minus x if put this value divided by x, okay, into x sin x, x sin square x. You can, if put x square, that is also written as if you put x square, then it is x cube. Clear? You can say that it divided by x square by sin square x by x, this one divided by x, it is written as like this one. After that, sin, better to write x cube here, 1 upon sin x divided by x to the whole square. Clear? X tends to 0, that is 1. X tends to 0, that is, you can say that 1 by x, sin x by x tends to 0, 1, and plus x by x, that is 1. So that is 2 and that is 1. Okay, that is 2 and that is 1. So we got limit x tends to 0, that is 2 and this is 1, and here sin x minus x divided by x cube. If put x this equal to 0, then we again got 0 by 0. So apply L'Hospital rule here. 2 into limit x tends to 0 sin cos x minus 1 divided by, that is 3x square. If put this value x is equal to 0, then again 1 minus 1 divided by, that is 0 divided by 0. So again apply L'Hospital rule, that is 2 by 3 limit x tends to 0 cos, that is minus sin x divided by, that is 2x, that is 2x. 2 and 2 is cancelled out, and again if put this value sin x by x, x tends to 0, that is 1. So minus 1 by 3 is the final answer. Make it. Now next target is now our next target is this question. If x tends to 0, infinitive, that is infinitive, and this one is also infinitive. Okay, so you can say that is infinitive minus infinite type of problem. Okay, it means indeterminate. So how can solve? First of all, take LCM. Minus x square into 3x square minus 4 whole divided by 3x square minus 4 into 3x plus 2. Clear? Limit x tends to infinity. If common is x square, then we got x 3x plus 2 minus 3x square minus 4 whole divided by now limit x tends to infinity, x square highest power, that is x cube. Okay, and this one multiply 3x square, that is 2x minus 3x square plus 4 whole divided by 3 minus 4 by x square 3 plus 2 by x. Okay, now limit x tends to infinity, 1 by x, upper power highest power is 1, only x, so 2 plus 4 by x whole divided by 3 minus 4 by x square into 3 plus 2 by x square. If x tends to infinity, that is we got 2 divided by 9. Okay, if put this value x tends to infinity, that is 4 by infinity, that is 0, or 4 by infinity, that is also 0, that is also 0, so 3 3 9. So finally we got 2 by 9 is the final answer. Make it. Now according to question, this one is a finite value, then what about a? Our motto determine a. Finite value means this equal to 2, 3, 4, 5, minus 5, minus 10, whatever the value means real value or existing value. Okay, and if x tends to infinity, then we got, that is infinity minus infinity. So if rationalize, then we got x to power 4 minus x plus 1, and that is ax square minus a to the whole square divided by under root of x to power 4 minus x plus 1 plus ax square plus a. Clear or not? If rationalize, this one plus ax square plus a. Then we got numerator like this one and denominator like this one. Okay. After that, x tends to infinity. X to power 4 minus x plus 1 minus ax power 4 plus minus a square minus 2a square x square divided by under root of x to power 4 minus x plus 1 plus ax square plus a. Limit x tends to infinity. This one is a finite value, means 1 minus a square into x power 4. After that 2ax square minus x square. After that minus x plus 1 minus a square whole divided by, that is x power 4 minus x plus 1 plus ax square plus a. Clear? Now limit x tends to infinity. This one is a finite value. Finite value exists if highest power, denominator highest power is x square and numerator highest power is x power 4. If this one is 0, then highest power is x square, numerator highest power is x square and denominator highest power is x square. Clear? Then we got finite value. It means only possible if 1 minus a square is equal to 0, means x to power 4 coefficient is 0. Then what about a is plus minus 1. Okay, plus minus 1. If a is equal to plus minus 1, then we got x to power 4 coefficient is 0, and then we got finite value of that question. Clear? Now, clear or not?